Hi, this is O'Connor. Yes, you got me. And we're up to chapter 6. Yes, and we're still in this hexagon. We're going to finish it, preventing and detecting fraud. Let's get into it, shall we? Data-driven fraud detection. And I'm just thinking, wow, what a boring name for a topic. But let's make it interesting in this episode, shall we? What are we talking about? We're talking about describing the importance of data-driven fraud detection. And I want to explain some of the steps in the data analysis process. We're going to talk about some packages very, very briefly, and then probably spend a little bit more time on the principles of data access and the basic data analysis procedures for fraud detection, including the Matassos matrix. And then finally, in part 2, because this first session may be a little bit long, we're going to look at how fraud is detected by analyzing financial statements. And I'm going to take you through an AI approach to how to set up the prompts for an AI to help you to analyze financial statements. So let's get into it, shall we? All right. So you know the different ways organizations fight fraud and fraud prevention. You know that's the best way, where we are creating a culture or we're eliminating fraud opportunities, but that is not always perfect. And there's some holes in the setup of most organizations. So some fraud is going to get through. And that's why we have at the top a theft act, the opportunity for concealment, and then there's an opportunity for conversion. And so under fraud detection, we are looking to try and detect any one of these three areas, but most importantly, the act of the theft. Now in this part 1 of chapter 6, I want to look at data analysis process, the data analysis software, and data analysis techniques. So let's get into it before you all go to sleep. And even before we get onto data analysis processes, get this, there's a difference between fraud and errors. Errors happen in organizations, in life, all the time, but they are not intentional. There are always problems with systems in organizations that cause errors. They are not frauds if they are not intentional. They do not represent fraud and normally not a result of legal action. Some ways, errors may lead to fraud symptoms. That's why we learned in last chapter, take symptoms as a red flag, but also with a grain of salt until you get further evidence, corroborating evidence that points you in the direction of fraud up here rather than over here. It is an error. All right. So fraud is the intentional circumvention of controls by intelligent human beings. Yes, perpetrators cover their tracks by creating false documents or changing records in data systems, and lots of things can happen. So get this, all right? You've got your symptoms, but sometimes symptoms represent errors and not fraud. Okay. What about audit sampling and fraud? Comparing the auditor's job and the fraud investigator's job. Well, audit sampling is an effective analysis procedure for finding routine errors spread throughout the data set. And audit sampling is the backbone of doing the audit. So you can come to a true and fair view that the financial statements represent the economic status of the organization. But that is not what fraud is about. Fraud examiners are out there to strive to complete full population analysis. It's not enough to say as an auditor, oh, there's no fraud because in the 5% of the sample that I've analyzed, there is no symptoms, there is no errors, and there is no malfeasance going on. It is not enough to say that from a fraud investigation point of view. So full population analysis is often the preferred method in a fraud investigation. The data analysis process, remember, we're looking to look at 100% of the data, and we want to take a proactive approach. And it's all about taking control of the investigation process, whereas sitting back and waiting for the tips or symptoms to arise is not very proactive. Of course, this may be the second step after you have been made aware of some symptoms of fraud that we talked about in chapter 5. So the investigator here makes the hypothesis and tests to see which are supported by the data. So we might start with a symptom and then look to the data analysis. But let's not just start there. First of all, we need to understand the business. Then step 2, identify the possible frauds that could exist. Step 3, catalog possible fraud symptoms. And the whole step 1 may have been started by the fact that some symptoms have already been red flagged and brought to your attention. Step 4, this is where you use technology, which is what we're talking about in this chapter. We're going to analyze the results and investigate symptoms further and do follow-up. So there's the basic steps that we are following. And we're basically in the middle section after we understand the business and identify possible frauds that can exist. So if we look at the data analysis process, we could put it into these 6 steps. In the previous slide, there were 6 steps, but here they are: understand the business with subcomponents, identify possible frauds, catalog possible fraud symptoms, use technology to gather data, which we're going to spend a little bit more time on today, analyze the results, and finally investigate symptoms. Proactive investigation. Yeah, that is what this chapter is all about, being proactive there. We're on the front foot. We're not on the back foot. So let's step 1, understand the business, because the same fraud detection procedures cannot be applied generically to all businesses or even to different units of the same organization. And understanding the business could be you go visit the factory, or you find out who the competitors are and study them and maybe get general information to compare with competitors. Interview key personnel, analyze the financial statements. We can get AI to help you with that. We can review process documentation and work with auditors and security personnel and observe employees performing their duties. Wow. So next is to identify possible frauds that could exist. And this is where we want to brainstorm the potential frauds. Like, is it financial? Is it operational? Is it cyber? Is it corruption? Now, we haven't talked much about cyber fraud, but the general popular frauds in organizations up until recently have been financial fraud, operational fraud, stuff like asset misappropriation by employees inside the organization, and corruption, which could be employees getting kickbacks or working with bribery with vendors outside the organization. We talk more about that in later chapters. But cyber fraud, we might have to leave to later this semester. Now, after we brainstorm potential frauds, given, the red flags that have come to you, maybe in terms of the symptoms, now we want to identify key players. Who are the likely internal players that could be involved? Employees, management, executives, or external players, such as vendors, suppliers, customers, or hackers in the case of cyber fraud. And then we can go to what symptoms could be present. So in some ways, step 3 could possibly exist before step 1 and step 2, because you have been brought in on an assignment because some of these fraud symptoms have already been red flagged through a whistleblowing system, or through some other observation in the organization. Wow. And so we do talk about fraud symptoms in terms of those 6. Remember, analytical, behavioral, lifestyle, control, accounting, tips, and complaints. And remember, which one of these is not a real symptom? And that is tips and complaints. And do you know why? Yes, you know why, don't you? Because you cannot trust all tips and complaints that you receive, because there could be other motivations of the tipsters or those complaining. All right. But so that's why we have to treat it as a symptom. Remember, symptoms are red flags. they are not prima facie evidence of a fraud on their own. It's a starting point. All right, let's get into the step 4. Use technology to gather data about symptoms. So we could use SQL, which is structural query language, queries and scripts. I remember learning that over 20 years ago. I had so much trouble learning SQL, and I was glad I got through that basic unit, and it was just a basic unit in my postgraduate studies. But the big thing I learned from SQL is it's basically a very powerful analytical tool that enables you to analyze millions, hundreds of millions, if not billions, of rows of data. So it's very powerful in that way. And you couldn't imagine having all of that data in an Excel sheet, but it's quite common to have that data in a giant relational database like Oracle, Microsoft, the IBM, the SAP, the Postgres SQL, the MySQL. As you can see, the Fortune 500 companies have these big databases. They don't just keep their data in Excel sheets. All right. So the SQL is a very strong, powerful data analytics language. Then we can analyze the results. Once errors are refined and determined by examiners to be likely indications of fraud, they are analyzed using either traditional or technology-based methods. So we're screening the results, we're undertaking real-time analysis. So get this, the advantage of these data analytics approaches is the investigator takes charge of the fraud. I'm in charge. I'm in the driver's seat. I have my hand on the data analytics steering wheel. I can type in what queries I want to test. Okay, great. I'm in control. However, the drawback is it can be more expensive and time intensive than the traditional approach. It does take time, and it takes an investigator with the talent for knowing how to steer the data analytics algorithm to pull out the information that will enable you to say yes or no to possible red flags of what the symptoms of fraud are raising. All right. We're analyzing the results. We can screen the results using computer algorithms and real-time analysis, of course. We can use the data analysis software. And what I'm going to show you in part 2 is how we can use AI. Since all of us have access to AI, it's much easier than trying to get access to any of these programs. But just be aware, here are the links to a very popular one, the ACL Audit Analytics and Caseware's IDEA. These are 2 powerful software programs in the marketplace today. Data access. This is where I want to spend the last area of part 1 going through. And there are 5, 6, 7, 8 items I want to come through. But with data access, we can open database connectivity. We can text import. We can host a data warehouse. But the most popular approach to data access is to use open database connectivity. What does that mean? It's the most popular among auditors and fraud investigators due to its robust querying capabilities, real-time data access, and flexibility. Text import methods are widely used for their simplicity, and hosting a data warehouse, well, that's useful but less popular. Okay, when you're a fraud investigator and you're brought in, it's better that you can connect into the relational database that the company already has through the OBDC. Okay, now I want to take you through the data analysis techniques. Each of these in more or less detail, but let's go through them so you are aware of them, and some of them you can try on pen and paper and using examples in Chapter 6 of the textbook. The first one, of course, we need to prepare the data, right? Conversion of the type, the consistency of values, descriptives, time standardization. Sometimes this is a very time-consuming task and may take 10 times longer than the data analysis task. Because you need to clean the data. You might need to clean the data looking for different values or different columns that haven't been regularly or properly input in the first place. And there may be little problems where they may have put in a comma in some data entries and they forget the comma in another data entry. So therefore, you need to find a way of getting around the fact that some of the data has commas and other data does not have commas. And it's just a matter of being aware of these problems in the data to begin with. Digital analysis is the most popular. It's the art of analyzing the digits that make up number sets like invoice, amounts, reported hours, and costs. And the textbook talks about Benford's law of probability values, like just after World War I, before World War II, about as early in the last century, where Benford found that if you look at an array of any data from any organization, it's more likely that the data digits are going to be starting with ones and twos, threes and fours, more often than fives, sixes, sevens, eights, and nines. Wow, amazing. So, and we can use that to investigate outliers. So, for example, if we look at the supplier graphs behind me, you can see that if we look at all of the invoices given to us by supplier 1, the first digit is most common, supplier 2 most common. But if we look at the actual data for supplier 3, you can see that over 10,000, 11,000 invoices, notice that digits 8 and 9 appear equally or more common than digit 1. So that's a kind of red flag that you can say, oh, let's have a look at a little bit more detail at the contracts that we have been entering into with supplier 3. Because supplier 1, 2, and 4 look more normal according to Benford's law. Now, just keep in mind that this law is a kind of shotgun approach. It is a way of maybe cutting down the data from 400,000, if this represented 4 suppliers, down to 100,000, representing 1 of 4 suppliers. But you still need to spend time looking at the 100,000. And then you may go into that 100,000 to look at those invoices that started with 8 and 9, and still there may be 5 to 10,000 of those invoices in that 100,000. So at least you can cut down from 400,000 down to less than 10,000 and continue your data analytics from there. So that is how Benford's law can help. It is a shotgun approach. So it doesn't allow you to pinpoint the final red flag, but it does enable you to filter the data into areas where red flags are more likely to exist. Wow. All right. And so next we have stratification. This is where you are asking the SQL program, the applications like ACL, IDEA, to give me data according to demographics, geographics for a particular time period, different categories, and so forth. Quarterly data in terms of quarter 1, quarter 2, quarter 3, quarter 4. As you can see over here, we have the original data, but then I can ask the SQL program to give me the data by the North region and South region. And that may enable me to compare the data in the North with the data in the South. Now, increasingly, there's going to be AI programs out there that are able to do it for you and you not reliant on the SQL analysis itself. But be careful, because you cannot just take this data and put it into a cloud-based AI program without being aware that you are taking private data and putting it into the public domain. So the AI in the cloud public domain can do a lot of this stuff already, but forensic investigation is all about private investigation. And you cannot just make that investigation public in order to use your favorite AI machine learning program. Therefore, in the future, what is going to increasingly happen is that forensic accountants, companies, will have proprietary AI programs to actually work the data against without that data being accessible in the public domain. Wow. Anyway, a little bit on the AI, we'll talk about that in part 2, but there's the stratification. Let's go on to summarization and time trend analysis. Again, very similar. It's an extension of stratification. It's a summarization technique that produces a single number that summarizes each graph. In this case, the single number is the amount of spending, and you can see it just goes 100 no, 100 no, 150 no, 100 no, 200 no, 300 no, 600 no, okay, 800. And you see, let's pull out the instances of transactions that were written around the 22nd of January to the 5th of March. And then that enables us to pinpoint areas that we can dive deeper to look for that needle in the haystack. Wow. Okay. That is what we mean by summarization and time trend analysis. Fuzzy matching is something that is a little bit more of a manual approach rather than a digital approach. So let me explain in terms of a scenario where we are trying to find a customer name in a database of thousands or tens of thousands, and we might ask the SQL program to not just look for Jonathan Smith, but look for a different spelling of Jonathan Smith. What about John Smith? What about Jonathan Smithy? J. Smith, John Smith, Jonathan Smith. Any of you would know what I mean by this fuzzy matching if you have had to change your address in Australia and you go to the post office, you pay them $100 to enable the post office to reroute your mail from your old address to a new address. And the post office will give you a form, and you can have 4, 5, 6, or 7 different ways of writing your name that will enable the post office digital system to recognize and reroute your mail, because you know, and I know, that not every letter that you get from the bank, you get from a government institution, that you get privately, you get from vendors, you get from your friends, not all those mail spell your name in the same way. Some of them have your middle initial in, some of them have middle initial out, some of them have a different vowel, and so forth. So you know what I mean? That's what we mean by fuzzy matching. Wow. Real-time analysis. We're near the end of this part 1. So an example of real-time analysis is where we do network security monitoring to detect and respond to potential security threats like firewall logs, intrusion detection systems, server logs, all right, and endpoint protection logs. So real-time analysis becomes probably more important in preventing and blocking cyber crime, because you need to be able to prevent and stop this sort of stuff in real time, because it happens so quickly. And sometimes the timestamp can come and go. You need to pick it up in the process. You need to go back and look at when it started, when it finished, to find out what data has been hacked and how much data was lost, and so forth. That's what we mean by real-time analysis. So it's similar to traditional accounting controls because it works at the transaction time, but it's distinct technique because it specifically analyzes each transaction or fraud rather than for accuracy or some other attribute. All right. So we're looking at the actual time that time window that something has occurred. Near the end here, the data analysis mitosis matrix. This is again a manual approach to data analysis, where you may even get a data analytic program to list out your winning vendors on various contractual competitions that you have run in the last 12 months. And here we have 4 contracts, 4 winning vendors, and notice that 2 of them have won, but the other 2 have lost in each of the time. And maybe they have the same likelihood of winning based on some attribute, but in the end, they didn't win. And so this may help you to figure out that, well, Under Inc. never lost any bid. It was the bidding winner many times, whereas Direct Corp and Danny Corp, which may be quite equal to Under Inc. on many aspects, but they never won. And it may raise a red flag to say, well, hang on, let's have a look at Under Inc. in a little bit more detail. Is there anyone in that company that is in personal relationship with our employees? Is there anyone in that company that has other type of relations outside the organization with employees in our organization? Another example is looking at employee IDs and just having a look at their travel, their meal allowances, office supplies consumed. And we're just looking at generally which employee may be taking unusual advantage of the generosity of the organization to reimburse for meals, for office supplies, for travel, etc. Again, this is something that in many ways could be manually done. And so that's what a mitosis matrix is all about. It's a way of setting out data in a manual way so you can visually compare and visually help just zero in on a particular employee or a particular contract that was given recently. Wow. There you have the different ways organizations can fight fraud in terms of fraud detection. What I took you through was very briefly the data analysis process, the data analysis software, and data analysis techniques. Not that you have to know every little detail about these, but you need to be aware of how are each of these different techniques useful to you as a fraud investigator. Some of them are useful by having an eyeball manual analysis like the mitosis matrix. Others are more useful for getting a digital analysis by looking at real-time analysis, for example. And so just be aware, horses for courses. Different data analysis techniques are useful for different ways of zeroing in on the data. As you, the fraud investigator, take a proactive approach, remember, we're on the steering wheel, we are in control on this fraud investigation, and we're trying to delve into those red flags that were raised by the various symptoms to find the actual fraud that has taken place, if some fraud has taken place. This is the end of part 1. Stay tuned and see you in part 2. Bye for now.